Hi, everybody, and welcome to the Firmo webinar. Today, we're going to be talking about how you can write smart contracts on the blockchain. We're joined by Gury and Ariel, who are the co-CTOs of Firmo, and together they have over 40 years of experience in tech, and they're going to be answering some of the questions that you submitted to us on Telegram. And before we dive in, can you two tell us a little bit about what you guys are doing at Firmo exactly and what your role is?
Yeah, sure. Hi.
Hey.
We're basically building the pipes underneath Firmo. We're going to use the current Firmo compiler to be able to compile the Firmo parts, and we're building everything else from scratch.
Got it. So our first question comes from it's very basic actually, and it's saying, what is a smart contract and why are they useful? So for someone that doesn't know what they are and how to use them, can you give us an example and maybe a use case to better understand what smart contracts are?
Yeah, so the smart contracts are basically the tech equivalent or the decentralized equivalent of a hard copy contract from real world. So for example, if you have rent you need to pay, you have some contract with your landlord, and you need to pay him according to that contract, according to what is defined in the contract, and it's up to you and the landlord to actually comply and do whatever is written in there. So a smart contract is the equivalent in the Ethereum or the crypto decentralized world. We have Ethereum, we have other blockchains that have smart contracts as well. And it basically is the ability to run predefined code on that blockchain. So for example, you can define that according to a specific schedule, Ethereum passes from one counterpart to the other, and that will automatically occur by the contract. So that's basically it. So nobody actually needs to do it. The contract itself actually executes whatever needs to be done.
Plus, to complement on what Ariel just said, in a more dev aspect, like a smart contract is basically the equivalent in a decentralized world for your backend. Like this is where you save your stuff, and this is where you run your backend code to support all your clients.
So our next question comes from Pablo, and he's asking, what is the pipeline of a smart contract? And he mentions that he'd like it to be elaborated from creation to deployment, approved, and execution.
Okay, so I'll answer like in the Ethereum context, because I think that's the more relevant one. So basically, the first thing you need to do in order to deploy a smart contract is to actually learn one of the EVM supported languages. So there is Solidity, for example, which is the most common one. There are other languages. There is, for example, the language that we're writing and promoting, which is called Firmo. And all these languages actually, once you know how to write using them, you can actually define smart contracts on Ethereum. And you can write, as Gury said, like any other piece of code, you can write your smart contract. And once you're done, there are a few steps of testing. Now, it's very important to thoroughly test smart contracts automatically and manually, because it's very hard to fix or do updates to a smart contract, and we'll get to that in a few minutes. But basically, the first thing you need to do is actually implement the smart contract in Solidity. Once you have that, you can compile it locally on your machine and execute it locally on your machine and test it. Again, write a lot of auto tests to cover your code. once you're sure everything runs locally as expected, you can actually also install a local Ethereum node and actually run it on a local testnet. And once you're ready, you can actually deploy it to a public testnet. And from there on, deploying it to the mainnet is the same action, just changing the network. So that's basically how you write and deploy smart contracts. The deployment is actually a transaction on Ethereum, so you should expect that any contract deployment actually costs money, costs gas.
Yeah, each of like the creation, deployment, approving a contract, and executing a contract, each of those costs Ethereum gas.
Now, your contract itself also consumes storage. Now, that storage is actually real estate on the blockchain. And for real estate, as you probably know, you need to pay. So any amount of memory consumed on the blockchain also costs you money. So that's it can get to big sums. And another thing that costs money is publishing your contract and publish events. That's another method of storing persistent data on the blockchain, a much cheaper way of storing data. So you have like a normal memory you can store in the blockchain, and you have throwing events which actually record as a log, which is also a kind of way of storing data.
Kind of as a follow-up, can you elaborate what is gas and how it works within all of this?
Yeah, so maybe I'll give it like a shot. Basically, the first vision in Ethereum, and my read is later on the competitions, is we want to build like a global computer. So Ethereum uses like the underlying Bitcoin network, and then on top of it, it builds like it changed the consensus protocol, and it built like a way to run code in a decentralized manner. This way is super costly, super slow, and if you don't need like the things decentralization gives you, you're in the wrong neighborhood. Running code in Ethereum costs, last time I checked, it costs something like 400 million times more than running it on AWS. So if you're not trying to scam people to give you ICO money, and you really try to build a product, if decentralization is not something you really need, it's like a huge error. But the way Ethereum runs this code is by incentivizing a miner with gas money. So it's quite like, maybe Ariel can elaborate on it a little bit more, but it's similar to the fees you pay on Bitcoin. To run that global computer, you need to pay in gas. You want to?
Yeah. So basically, gas is the way Ethereum actually balances the network, because as Gury said, it's a way of paying miners. Now miners, if there is a lot of congestion on the network, then miners will obviously choose the transactions that yield them the most amount of money. And in Ethereum, you pay miners using gas, and gas is basically has a conversion rate to Ether. Now, in times of congestion, the gas prices go up. In the same way, like when in the US you had the energy crisis in the 70s, the gas prices went up because people were willing to pay more dollars per gas unit. So the same is in Ethereum. In Ethereum, gas is defined as an independent entity, but has a conversion rate to Ethereum. So, and the person that is willing to pay a higher price on gas will gain precedence.
I think what they're asking here and hoping to hear a little bit more about is how you incorporate gas into your smart contract if I'm writing one.
So basically as we said, to write a smart contract, you need to write in a certain language like Solidity. Solidity compiles into EVM bytecode, which is like the machine code of Ethereum. Each operation, EVM operation, has a gas cost. So if you, for example, want to run a multiplication of two numbers in a contract, that will have a certain gas cost. And as you write like a certain method that people can run on your contract, you do certain programmatic operations in that function, and that accumulates to the gas cost of running your function. So if you have a very complicated contract, running it will consume a lot of gas.
Yeah, in theory, you can have some lame code cost a lot more than right after you fine-tune it and make it more robust. Like writing bad code results in costing more money.
So it's not that you utilize gas when you write a smart contract. It's more than you need to be alert to the amount of gas your contract is consuming, because you need to remember that the gas is paid by the person that is executing your smart contract. If the person is not going to supply enough gas to execute the function, the gas will be wasted and the function will not execute. So it's very important to understand the risk of having like a high costing function. There are a lot of examples of smart contracts that just cost too much and cause a lot of frustrations from end users. So that's a good point.
I think that's a very important takeaway for anybody who's working on a project and hoping to develop smart contracts. So our last question comes from Avi, who, it's kind of a nice way to sum up, asked, how would you recommend a beginner to get started writing smart contracts who wants to enter this space? Where should they go to learn?
Well, I'd start with Google, then Stack Exchange and places like that, places where you learn coding in general. We can actually paste some links to quite good videos from like known places, but in general, the learning curve to get into crypto is endless. I'm still like somewhere in the beginning, I'm sure. And like most of the code is open sourced. I would also suggest reading, getting into Zeppelin, because they have a lot of open source audited code, and they're like we are building our contracts on top of Zeppelin.
Yeah, if you're locked on Ethereum, I would definitely check out Zeppelin, and I would check out first of all, I would start from obviously from the Ethereum yellow paper, and from there there are a lot of good Solidity samples. You can go to Firmo and learn Firmo. That's a good option as well. What I would suggest doing is also experimenting with. Yeah. It also depends on the knowledge that you have before. And for example, if you're a veteran .NET developer, it makes sense to explore the Neo front, because Neo is C# based, and you can write smart contracts in a more familiar environment. So that's, and also it's going up right now. So I think I would definitely look into Solidity and Ethereum, but I would also have a glance at other platforms, and there are a lot of them like look very promising. EOS, as I mentioned, Neo. There are a lot.
Half of the top 20 are either Ethereum or Ethereum competition that runs smart contracts in a similar manner. I would check, I would know about them and read about them, because maybe what you want to do, what Avi wants to do in the long run might work better for him on one of the competitors. I don't know. Once one of those gets a lot of traction, it's a lot harder to move forward. So a lot of times you get modern stuff on the like smaller coins, and you have to choose and gamble. But in general, like that's the stuff that is being hyped now. Like half of the top 20, this is their title.
I want to just reiterate one point that we talked about, and I think that it's super critical that especially a newcomer to this area knows about, is that it's very problematic to fix bugs in contracts, and you need to really define the contracts in a very smart way in order for it not to cost hundreds of thousands of dollars to run such an upgrade, and I'll explain shortly. Basically, when you have, for example, if you write like a smart token for an ERC20 token, for example, is a perfect example of a smart token, a smart contract. It manages balances of people holding that coin, and therefore, if it's a very successful coin, it will have like a map of a lot of Ether addresses and their balance. It will have a lot of storage within it. So if, for example, that contract has some kind of bug and we need to deploy a new contract, it means that we need to migrate all the balances from the old contract, which is going to be obsolete in a second, to the new contract before we bring it up live. So people will have their balances in that contract. And once we do that, we need to inform all the exchanges that we modified our contract address, send them the address, and only when all the exchanges move to the new contract, then it can actually be, the old one can be deactivated. So you can see it's very, very complicated.
Extremely complicated.
And plus, the cost is calculated in real time, and it depends on congestion. So for instance, if we go back to CryptoKitties instances in the past where the network was congested, the costs were so crazy, just the deployment of like hello world contract would mean $100. Okay, just deploying the contract and have it on the blockchain. Each like that would be like quite a minor operation.
I'm talking about like things that are much more complicated, coordinating things with exchanges and stuff that you really don't have any way of solving in less than a few days of coordination. So basically, when you do smart contracts, it's very important to think about the structure beforehand. And for example, the way to relieve this is to actually separate your contract into multiple subcontracts, and have the storage in a very minimal like storage contract, which is only responsible for storing like the balances, and then having a bug there is very unlikely. The amount of logic there is very small, and then you can have the main contract, or the contract people are interacting with, actually using that storage contract as an external service. And then if you have any kind of bug, you can actually upgrade only the logic contract, and you can go even further and have like an API contract that is only responsible for mitigating between requests from clients and your other contracts, and like a gateway. And again, it will be very slim and have very small amount of logic, and then it won't break. So you can have one gateway contract, one storage contract, and in the middle you can have a logic contract, which is more likely to have bugs, but is easier to operate. So it's really important to lay out your contracts in a smart way so you won't get stuck once it's deployed and you don't have any flexibility of upgrade.
Fantastic. Thank you, guys. If people who are watching have any more questions, we are going to do another webinar, so you can submit your questions in the Firmo Telegram group that you see in the description below. And we will also add the links that Gury and Ariel talked about, so you can go ahead and check out those different resources. Thank you guys for your time, and we'll talk again soon.
Okay, thank you, Annalisa.
Thank you.
Bye.
See you soon. Bye-bye.